ini kan
પાછળ અહીંયા પોડિયમ આ લોકોની બિલ્ડિંગ અહીંયા હા એ બિલ્ડિંગ
Oh, very
અહીં નીચે ચાલવાનું બહુ સરસ
Oh,
છે.
fine.
અહીંથી છેક ત્યાં સુધીનું પોડિયમ
this is nice.
આ પવન તો આપણે ગણીએ તો સહન ના કરાય એવું બંધ જ કરવો પડે
No, very nice.
આ પવન તો આટલું તો ખુલ્લું જ
આટલું તો તમે enough લાગી છે. Yeah.
હવે હમણાં જો અહીંયા આ બાજુ તાપ ચાલુ થઈ ગયો હવે આખી બપોરે અહીંયા તાપ રહેશે
બેડરૂમ
Very nice.
આ બેડરૂમ એમાં ઓલ્ડર બનાવ્યા આવ્યા પછી એમાં
એમને લાસ્ટ યર
આપણે પછી બનાવ્યું 2 વર્ષ પછી બનાવ્યું
હા, જરૂરિયાત પ્રમાણે.
હા
જરૂરિયાત પૂરતી.
ના એક રેડીમેડ લઈ ગયો
સરસ.
તૈયાર કપડ
ફર્સ્ટ ક્લાસ
કોઈ હેન્ગર વાળું
અને એક આ બાજુ ને એક પેલું પાછું
અને હું આ બાજુ પાછળ આપણે પાર્કિંગ આ જુઓ અહીંયા જે બિલ્ડિંગ હતું ને પાછળ આપણું
તમારું થોડીક મોટી.
બિલ્ડિંગ નો સ્લોટ આગળ આવ્યો
એના કરતા આ મોટી.
પેલું કેરીન ઝાડ અગાસીમાં આપણા અગાસીમાં આવતું હતું યાદ છે અગાસીમાં આવતું હતું આપણે ચા આટા મારતા હતા યાદ છે હા આ છોકરાઓ બધા આયુષ ભૂમિ વૈભુ પેલા મારા શાળાના છોકરાઓ છે ચિરાગ ના
આ જો ભૂમિ તો દેખા
ચિરાગ ના
અને
ચિરાગ ચિરાગ ના બે છોકરા
આયુષ તો ઓ માય ગોડ ફૂલ પવન એકદમ આખી વિન્ડો છે અને આ તો પણ છે કે આ તમારું છે
કોડિયામાં એટલે અમે વોકિંગ અહીંયા કરીએ નીચે પાર્કિંગ પેલી પાર્કિંગ ડાર્લી સેમ આવી પેલી બાજુ સેમ આપણું બિલ્ડિંગ પાછળ હતું ત્યાં
તો તમે તમારું vehicle તમને vehicle parking મળે vehicle parking મળે તમારે
આપણું કરવું
તો you can rent it
ના મને
કરી શકીએ પણ
they can rent it
કરી
they don't
શકીએ
have a car.
કરી શકીએ જોઈએ યાર એ તો નોર્મલ ભાડું આપણે લઈ શકીએ
હા એ તો છે
આપણે લઈ શકીએ અને આ લાલા વાળું બિલ્ડિંગ હા
હા પેલું થાય છે તે થાય જોયું ને
મળ્યા
મળ્યા
પણ હજુ તો આ 5 થયા છે પછી પેલી સાઈડ જે વધશે
આ હજુ તો કોમર્શિયલ પાર્કિંગ પાછળની પ્લોટ છે ને પછી પાર્કિંગ લોટ છે નીચે કોમર્શિયલ છે અને બિલ્ડિંગ મેઇન બિલ્ડિંગ અહીંયાથી ચાલુ અહીંયાથી ચાલુ
અને એટલે તમારે તે વખત થોડો બ્લોક થઈ જવાનો
એ ને આ એ લોકો એક્ઝિસ્ટિંગ મેમ્બર નાખે આ સીધો
આ સારું.
વેસ્ટ લોકો અહીંયા સુરત સીધો સાંજે અહીંયા તડકો આવશે હમણાં બપોર પછી તડકો આવશે જોજો ને
આટલું ફૂલ પરમેનન્ટ
બોલો
ના બહુ પવન આવશે
પછી શું કામ ચાલુ થાય તો રોડ ચાલુ થયા ને
એટલે તમારે અહીંયા પહેલું ઉપરનું જે પહેલું આવશે એ તમારે લાલા
હા મને ખબર તેઓ ત્યાં જ છે બધું મારે ઈસ્ટ વેસ્ટ બધું ફર્સ્ટ ક્લાસ કાકા કોઈ જાતની ટેન્શન નહીં કરતું નહીં આઈડિયો હેકની મારે આ બેડ હા ના ના એવું ના well maintained well planned થી with all amenities with writing with એનું રાઇટિંગ રજીસ્ટર કરાવડાયું અને સેલેબલ જે એરિયા જે હતો સેલેબલ ફ્લેટ્સ જે એના હતા એ ફ્લેટોમાં જે એમ્યુનિટીઝ આપવાનું એ જ એમ્યુનિટીઝ એને અહીંયા આપવાની એવું નહીં કે અહીંયા અલગ આપશે અહીંયા આપશે બધું રાઇટિંગમાં લીધું બધું અમે રાઇટિંગમાં લીધેલું એની પાસે હા ભાઈ આ સેમ આ બારનું પડી દીધું
Hello. Yes, sir. Okay.
શું રાઈટી
एक digit.
Oh, this is for you. Okay.
મારી માટે શું હું તો અહીંયા જ છું
અરે અહીંયા જ વાપરશે ને અહીંયા જ વાપરશે.
Yes, sir.
Earlier lecture, we have discussed about the structure mounted different kind of arrangement. One we discussed the vertical arrangement, and second one is horizontal arrangement. Here you can see the entire layout. Chemical industries or petrochemical industries, so that kind of equipment and piping layout exists. Such concern. Building. see the sketch of horizontal arrangement, can made arrangement. Then you see the different kind of layouts for piping engineering and process industries, or we call even the petrochemical industries or refinery industries. So that kind of arrangement essential this kind of industries. So before starting another kind of industries, pipe rack and arrange the general philosophy of piping layouts. So in general philosophy, the piping layouts. So we'll see the cross section of indoor process plant. So that kind of cross section exists in indoor process plant as indoor. So that kind of cross section exists piping industries. For this, to consider their overall plot plan, where we can place different equipments like pumps, and another is piping fitting components and different kind of building descriptions. So here see the pump house, analyzer house, and security office, and another is the trapo station. So that kind of situation arises in the piping industry. That kind of view we call the orthographic view. So earlier this is called as a 3D or isometric view piping layouts. Based on that, we can draw the isometric view plot plan that mentions the units or process units this in this refinery industries or petrochemical industries. So that kind of orthographic view we can draw in the drawing sheets. For this, so can use A0, A1, A2, A3, A4. So that kind of drawing sheet so we can use, and same time we can see the top view from different floors. Here, for reference, the top view from the fourth floor. So here we have drawn the detailed plot. So the industry name is not written, just for reference. So based on that, we can draw that kind of top view of any industry. So the equipments placed might be some process or the distillation equipments and the piping fitting components. So then we can draw their respective top view of third floors or fourth floors. Here again you see the top view, the fourth floor is the equipment. Earlier we have seen the detailed plot plan of the fourth floor. Here we cover the all. Now here we see equipment arrangements at elevation. There is 121900 that elevations are used on ground levels, and we can arrange the equipment. So this is the basic technologies where we are used in piping layouts. In piping layouts, we consider the main artery of an outdoor process plant is the pipe rack. Now we'll see the different kind of pipe racks. So different, there are 4 to 6 kind of racks are used. We call by later name, that is L, T, C or U. This configuration is based on the overall arrangement and site conditions. Based on the interconnecting the lines and location, the pipe rack is laid. So that kind of pipe racks are used in industry. The main artery of an outdoor process plant is the pipe rack because the rack is located in the mid of an outdoor plant. The pipe rack must be erected first. Hence, the development of structural drawing becomes one of the early requirements in a plant. To pass on the data to civil or structural groups, a civil scope drawing showing the width, the column spacing, and the design load is prepared. This load data should be included in addition to the dead weight specified for running meters. The thermal and occasional loading the piping will impart on to the structures. The latter will include the forces and moments depending upon the types of supports provided. The structural designer reinforce such as based on the pipe rack to overcome this forces and moments. Hence, a proper planning is required in the initial stages of design itself. So, the first step in the development of pipe rack is the generation of a line routing diagrams. A line routing diagrams is a schematic representation of all process and e-piping systems drawn on a copy of plot plan, or it could be planometric representation of the utility and process line diagrams. Although this regards the exact location, elevation, or interface, it locates most affected area. The pipe rack split the plant area into convenient parts. The pipe rack takes various shapes. First is straight. Step is straight and L shape, T shape, and C shape or U shape. This configuration is based on the overall arrangement and site conditions. Based on the coming outgoing lines and locations, the pipe rack is laid. You can see the different sketches can show the typical pipe rack layout for various plants arrangements. Smaller plants have the simplest yard piping as shown here. The first one is that kind of racks are generally used for smaller plants. The arrangement shown in this scale, the process and utility line enter and leaves at one end. Here you can see the enter and leaves at one end the battery limits. Now, in second stage, the presents the frequently adopted layouts with utility lines entering at one end. See, the utility lines entering one end and leave at one edge of the battery limits. So that kind of utility entering at one end, the battery limit and process line at the opposite end are straight through line. Layout conditions sometimes result. So here you consider the U-shape configuration adopted in process plant where we can design different kind of layouts. In larger plants, Yard piping will be more complicated and mark the T-shaped yard. So here is the T-shaped yard. The process UV lines can have and live on any height in the plant. And another configuration is the U or C shaped yard. Lines can appear and live almost everywhere. Mark force. Therefore, line can enter and live at outside the plant. Now, the combination of L and T shape. So here, this is the combination of L and T shape. So we call the complex lighting arrangement for very large plant. This layout can be considered as a combination of many simpler yard piping arrangements. Note, the configuration of pipe rack is not determined while doing the plant layouts. The arrangement results from an overall plant layout, site condition, client requirement, and above all plant reliability. Pipelines on the rack are classified as the process lines, relief line headers, and utility lines. The rack should accommodate electrical device as well the width of the pipe rack. So based on that, the width of the pipe rack can be calculated with the help of this relation, that is W equals to F into N into S plus A plus B, where F is safety factors. If here pipes are counted from the PFD, that is a process flow diagram, that is 1.5, and factor of safety 1.2 if pipes are counted from P and D diagrams, that is a process and instrumentation diagram. And N is number of lines in the dense area size 450 MB, that is nominal bores, and F is 300, the estimated average spacing. N is 225 millimeter if lines are smaller than 250 MB, and A is additional width for lines larger than 450 NB or for instrument cable tray or duct and for electrical cable. And B is a future provision 20% of F into N into S plus F. So already we are defined what is F, what is N, what is S and A. With the help of this relation, we can find out the width of pipe racks. Normally, pipe rack width is limited to 6 meters. If the width work out thus is more, then the arrangement to be done in multiple layers and the space requirement of equipment along with the excess influence the width of the rack. The arrangements are adopted. That is, here we can adopt the arrangement of the roof rack that is called as a simple T rack. So first type we call the simple column rack T types. And second one is double column rack with single tires. And third one is a double column rack with a double tires. So these are the illustration of racks. Depending upon the type of plant, the rack could be of steel, concrete, or combination of both. The spacing between the bent or column of the pipe rack is normally 5 to 6 meters. Wide spacing is necessary at a road crossing or where loading and access points are taken. Bedroom does also depend upon the type of crossing. So, header growth can create a problem of interference, which is often overlooked. The space on the rack should be accounted for this. The line which expands also should be properly guided to ensure the maximum effectiveness of expansion. Use the cooling or even rapidly cool. This is reflected the provision of the structural members known as spandrels connecting between the columns at the required elevations. The spandrels could be located along the external face of the column or on the center line of the same. If hydrocarbons are prevalent in the plant, it is common practice to fireproof to column just below the lower support rack support between. If air cooler or any other equipment is located above the pipe rack, the fireproofing is extended up to equipment support beam, and fireproofing is done rack column by covering these by plain cement concrete we call PCC. The expansion of the rack should also be thought while planning. It is normal practice to add additional tire on the top. To accomplish the same, the space above the column should be kept free. The piping, then we can consider different arrangement or configuration of the pipe racks. Alternative to the expansion, the rack could be planned for expansion outside, which is not prepared. This keeps the process equipment away. So, for this, we have to consider the different kind of arrangements. Overall pipe rack design must meet the current needs as well as the expansion plans without major modifications. Heavy large diameters piping may laid below ground or on slippery as established by codes. Now see the different equipments are laid down in the pipe rack components. Now we'll see the location of wall. So here wall locations, accessibility to wall and instrument should be primary concern while arranging the same on the piping process. Process isolation wall should be readable, readily accessible. The wall stem center line being at the elevation of 12,000 to 15,000 millimeter from the operating levels. If at elevated level, they can have chain operators. Walls located at low or high location can have extended stems to reach the excess SLs. One thing must be ensured that the stem will not be oriented below horizontal level. Then, utility lines have two groups of walls. One group is closely related to process and should be located having accessibility just like process walls. Other groups contain all isolating walls, such as block walls on headers, root walls on subheaders, and walls for future connection. These walls are seldom used and are located overhead. Temporary ladders accessibility is acceptable for such walls. Battery limit isolation walls can be provided with access platform. Walls being located on either side of the platform to Kunam is the spacings. Battery limit calling for a single tire pipes racks and the walls are staggered on either side the catwalks. When pipe rack enters a unit, the elevation changes may be required. Block walls could be installed on vertical leg. This case, this allows a relatively easy operation for 2 levels, 3 levels, or number of level racks. Then we can change the elevation above or below rack levels. And high point vents and low point drain walls are provided to avoid frustration during testing. These shall be pipe assessments. Now we'll see the design, pipe rack design and calculation. So with the help of this pipe rack design and calculation, so basically in design and location, so pipe racks are also used in secondary ways. It also carries the electrical wires, instrument wire, firefighting systems, lights, etc. Air cool or fan type heat exchanger are often supported above pipe rack to reduce the plant space requirement. Here you can see the typical arrangement of pipe racks and see the different kind of racks. You can use steel structure or RCC structure or slippery types. The slippery type we call the pipe tracks. In steel structure pipe rack, a steel structure pipe rack is a prepared lines up to 12-inch or 300 MB. And RCC structure pipe rack is prepared for lines above 12-inch. It is also used if the pipe rack height is above 10 meters. And third one is slipper type pipe rack, or we call pipe racks. Slipper type pipe racks are mainly used for pipelines above 30 inch. So what kind of documents required for piping developments? First one is a PFD, that is a process flow diagrams, and P&D, that is piping instrumentation diagrams. And next is a line list and line routing diagrams required for pipe rack developments. Pipe rack designing involves considerable planning and coordination with other engineering groups to deliver error-free work. So, kind of documents are required from different engineering sections. Then we'll see who design what. First one is here. We'll see the pipe rack designing is not a one-man army job. It involves a lot of engineering calculation and so required contribution from the different engineering discipline. Let us see which discipline is required. See, work done. It's done by pipe rack width, height and length calculation. It's prepared by piping engineering and submitted to structure and civil engineers. Calculation of pipes and equipments on pipe racks. These two things are prepared by piping engineering, submitted to structure and civil engineers. Now next work is size and type of members. Type of member means here column and beam. Selection as per different loads like pipe and equipment load, cable tray load, wind load, snake load on pipe racks. So prepared these structural engineers and submitted to civil and piping engineers. Now third is foundation calculation prepared by civil engineer and there is no need to submit anywhere. Now next one is a electrical cable tray calculation. So it is prepared by electrical engineer and submitted data to structure and civil engineers. And next one is the instrument cable tray calculation. These are prepared by instrument engineer and submitted to structure and civil engineers. And next one is fire proofing load. It is prepared by firefighting engineers and it is submitted to structure and civil engineer. So now we see the line spacing criteria. After that, see the line spacing criteria. Group the utility and process lines. This is very important. Keep hot and cold lines away from each other to minimize the heat transfer. And for easy up support to expansion loops, always try to keep the hot lines near to the extension or columns. If the lines are heavy, keep those lines near to the column to minimize the stress, means bending moment, on the horizontal beam or member. Do not get confused that if the line size is greater, the line will be heavier. No, it's not like that, as a gas filled lines will create less stress on the horizontal beam than the liquid filled lines. Once we can compromise with weight, but never compromise in case of temperature, always maintain enough space between the lines. We should avoid keeping a temperature sensitive process near high temperature lines. For instance, if the instrument air line is placed near to the high temperature line, it will absorb the temperature and can harm the instrument or instrument diaphragm. We should also avoid keeping the temperature sensitive lines near to chilled lines, as the other line can absorb the moisture and further it can be problematic for the particular lines. And in the hydrocarbon and chemical industries, avoid keeping utility lines below the process lines. Means the process lines will kept on the first tier and utility lines on the second. As in case of leakage of the process fluid, water may get contaminated, as the water line is a utility lines. It can be harmful to the person. In the food and pharmaceutical industry, it is mandatory to keep utility lines below the process lines to maintain the purity of the products. If possible, keep the supply and return lines near each other. As these lines are having minimum temperature difference and transfer it is, for instance, steam and condensate, cooling water supply, and chilled supply and return. Now next is balance. Balance the width of the pipe rack of different tires, water, air, nitrogen. Such lines can kept on any of the tires. There is no restriction to such utility lines. So here you can see the flange arrangement. Simple flange arrangement and staggered flange arrangements, that we can avoid the complex in the pipe rack arrangements. Then we proceed with pipe rack width calculation. So in pipe rack width calculation, we'll do a case study for pipe width calculation so that we can better understand the discuss points in line spacing criteria for pipe racks. Let us take one example. What kind of input is required? So here we required line size from 3 inch to 12 inch. This is called as line type, and line size and line types. All lines are process lines, and flange ratings, whatever we are discussed on this. So here we can use 300, 600, 900, 1500, 2500s, and 1500s, and 150 hundreds. And what kind of insulation is required? somewhere no insulations, and somewhere use the hot insulations. And for flange rating 625 right, so we'll use the hot insulation, and 900 go for hot insulations. Now next is insulation thickness. Kind of insulation is is required. In first case, there is uh, no insulation is required, means we call the Na not applicable. In second case, here line side is 12 inch, then we'll go for 125 millimeters. And third, that is 300 rating of the flange, go for no insulation thickness. And for 600 insulations, here hot insulation is required, and insulation thickness is 75. And another is 4 inch has 75 millimeter insulation thickness. And for 3 inch, there is no insulation thickness is required. Here no insulations. So with the help of this input data, we can place the line as per the line placing criteria. So here, with the help of this criteria, we can place the lines and with the help of this input read. So in first step, place the line as per the line spacing criteria. This is our first step. With the help of this step, we can place the data. Here, we can place the heavier pipe near the columns, that is 12 and 10-inch pipes. So the first step, we can place the heavier pipes near the columns, and we can refer this 3D here. Here once we place the lines, then we can calculate the distance A using this formula, that is half up beam plus gap 100 millimeter plus insulation thickness plus flange radius. So here we can refer this sketch for better understanding this relation, that is distance between structure to nearest pipe. So here we can see the flange radius on the red pipe, so we see the flange radius. And second one is insulation thickness below. If the pipe is insulated, if pipe is insulated, then we'll go for the insulation thickness. If it is not insulated, then we'll not use the insulation thickness, we'll write 0. Then next is a gap. So here you can see, here gap is 100 millimeter, and then half of the beam. So with the help of this sketch, we can understand this relation to calculate the distance A using distance between structure to nearest pipe. And in next step, we have to calculate the to put some values, the help of this data. For the ASMEB 36.10 or 36.1, and flange radius as per ASMEB 16.5. And here mark the NPS, that is nominal pipe size and ratings, and pipe radius and flange radius. So here we can consider this relation, that is half of the beam and gap 100 millimeters and insulation thickness. And next means a flange radius. So then we can go for the flange radius. So here to consider the NPS size is 10 inch and rating is 900 hash and pipe radius is 136 and flange radius is 272. And here consider this much insulation for this till the insulation. Here insulation thickness is given 125 millimeters. So simply we can put all values in this relation, and then we have to consider the distance between structure to nearest pipe. Help of this relation we can calculate the distance in structure to nearest pipe. Now here we can consider the beam size is 300 millimeter. The size is decided by structure or civil engineers. And similarly, distance G can be calculated with the help of, again, is a height of the beam and plus gap, that is 100 millimeters, and the relation. So that is, can consider this much distance to calculate the required flange radius. So here for 12-inch 5 NPS, go for the flange radius, that is 337. So we can calculate the G, that can be calculated here with the help of this relation to calculate the pipe distance B. Again, with the help of this relation we can calculate the B. We are already considered in the relation, that is A plus B plus C. So now we go for another calculation, that is B. So here to calculate the B, so with the help of this relation we can calculate B. This B we call the pipe to pipe distance. So through this sketch you can see the pipe to pipe distance, that is a larger flange radius, larger flange or line insulation thickness, and here gap is provided 25 millimeter gap and insulation of other pipes and other pipe radius. And here with the help of this sketch we can write the pipe to pipe distance, and that is B. Larger flange radius plus larger pipe insulation thickness. Here you can see the larger pipe insulation thickness plus 25 millimeter. Here gap is given between this flange to flange, and insulation thickness of the other pipes, and plus another pipe radius. So with the help of this sketch we can understand the relation for finding the pipe to pipe distance. So once we understood the relation for finding pipe to pipe distance, then we can substitute the values the for finding the relation B, C, D, E, and F. So with the help of this relation we can find out all terms A, B, C, D, E, F. And in force shape we can add the distance. Sorry, that is A plus B plus C plus D plus E plus F plus G. And with the help of this relation we can calculate the pipe rack width. If you substitute A, B, C, D, E, F, G, H, then we'll get the pipe rack width, that is 3295 millimeters. And in fifth step we have to add 20% future expansion to calculate the pipe rack width. Pipe rack width after adding the further expansion. So here first one is a calculated width, that is 3295, and 20% of future expansion. Then we have to add this calculated width plus 20% future expansion. So therefore here we will get the total pipe rack width, that is 1000 millimeters. So that kind of calculation is required in pipe widths. Now next step, that is the last step of this calculating the pipe rack width and different distances in pipe rack width should be rounded to the next 500 millimeters, which means pipe rack will be multiple of 500 millimeters. In step 6, now find the actual future expansion distance by subtracting the distance, that is A plus B plus C plus E plus A plus G, from pipe rack width with future expansion. So actual future expansion to calculate, that is here actual future expansion we have to subtract calculated pipe rack width minus means 4000 minus remaining distance, that is A plus B plus C plus E plus F, and we'll get the actual future expansion. If you subtract, that is 650, 585, 410 and 260 and 475 and 590, then we'll get the actual future expansion, that is 1030 millimeters. So with the help of this step we can calculate the actual future expansion. So with the help of this actual future expansion, so here we can calculate the actual future expansions, that is 1030 millimeters, and then we can mark the actual future expansion, that is 1030, wherever we place the future expansion in process industries for pipe racks considering the 4000 millimeters, and with the help of future expansion as well as actual expansions. So that kind of pipe rack calculation represents through this gauge entire rack width calculation representations. So here we'll stop, and if you have any questions, any doubts, so we can discuss your doubts. Yes. Yes, Nikhil, Karthik, Pratik.
No, sir, no doubt.
Okay, fine. Aditi. Okay, anyone, any doubts? Kaveri? Pratik? Okay, fine, fine. Okay, no doubts. Okay, fine. Then we'll close this session here and we'll continue in next lecture. Okay.